This is the Unit 2 skill video for Skill 6 on triangle proportions. So recently we've been talking about similar triangles, all right? And so if two triangles are similar, we need to know what two things are true about those two triangles. Okay, so for your notes, let's write if two triangles are similar, then. Now the first thing we've talked about is their angles, right? There are three matching pairs of angles that are congruent. Okay, so the first thing, three pairs of corresponding angles. That means the same as the ones that match, right? Of corresponding angles are congruent, right? They're exactly the same measure. Okay, then the second thing that was true had to do with the sides, right? Now the sides were not identical in length, right? That would be congruent triangles. But the ratios were the same of those corresponding sides. So if two triangles are similar, then there are three pairs of corresponding sides that have the same ratio. Okay, and having the same ratio means those sides are all proportional. Okay, so I'm also going to write that, proportional. And this video is on triangle proportions, so it does have to do with using this second piece. We're going to use the fact that there are these corresponding sides that are proportional, so having the same ratio, to help us find some missing side lengths or to solve for x when it's a part of one of those side lengths. Okay, so let's look at a few examples. So for our first example, I'd like you to draw this picture. Okay, you're given that these triangles are similar, and we're going to use that fact to find the missing side, the one with the question mark. Okay, so we know that if these two triangles are similar, then all of those matching or corresponding sides should have exactly the same ratio, right? So our goal is to find this side length here in the smaller triangle, and it matches with this side of 33 in the larger triangle. Okay, so we know that the side we're trying to find, let's go ahead and call it x, right? It's our unknown. It matches with 33, and then also the 28 side matches with the 42. Those are the corresponding sides. And if those fractions, those ratios are supposed to be equal, let's go ahead and set them equal to each other as an equation. So I'm going to take the sides that I know, and I like to do the larger side or the larger triangle over the smaller triangle, but it does not matter. You could switch those and do 28 over 42. And now I'm going to set that equal to a fraction. Now I know I don't know this side length with the question mark, but we're going to call it x, and I know that it matches up with the side length of 33, and so if I put the larger triangle length again on the top over the smaller triangle side length, which is x, I've created an equation that's called a proportion. Okay? So when you have an equation that is a fraction equal to a fraction, we call it a proportion. And the easiest way to solve a proportion, because now we have this x variable in the denominator, okay, and we need to get x out of the denominator, this is where we can cross multiply. I can multiply both sides by this x. Okay, so I'm going to end up multiplying this 42 by x, so it gets out of the denominator on the right. And then to get the 28 out of the denominator on the left, I multiply it over with the 33. So it's called cross multiplying. So that's how we solve proportions. We cross multiply. Okay, now let's see what that leaves us with. When we multiply x times 42, we get 42x. Okay, then bring down the equal sign. And then we multiply 28 times 33. That is 924. Okay, to solve, we have one quick step. We divide both sides by 42. Okay, maybe we plug that into the calculator. And our answer is 22. Okay, so for those two sides to be proportional, our unknown side in that smaller triangle would have to have a measure of 22. Okay, so this is how we solve for these missing sides, is we create this equation here called a proportion, and we cross multiply to solve for our missing side, x. Let's look at a second example. So here's example number 2. So take a moment to copy this picture and the side length measurements onto your notes. You can pause the video if you need to. Now our question mark is on the side length of the shorter triangle, or the smaller triangle. Okay, right here. That's the length that we want to find. Now notice we have enough measurements here to help us, we have information about all three sides, basically, some information. So we only need to use two corresponding pairs to create our ratio. Okay, so we need to find a pair that we know the small triangle side and the long triangle, or the larger triangle side. And we do know two of them. For example, we know a 6 and the 12. We know that those match up. We also know 9 and the full length of 18. Well, we can use either of those, right? Now, you might already be thinking you know the question mark angle based on these measurements, but let's go ahead and set up our proportion. Take one of those two pairs, okay? Let's say we use the 6 and the 12, and we make a proportion, or our ratio. So like 6 over 12. This time I did the smaller triangle over the larger triangle. That's fine. And we're going to set that equal to a fraction where we have our unknown, or our x, right? X is going to be that unknown side. And then we know the matching side is this long side here of 22. So again, I need to put the smaller triangle on the top, the larger triangle length on the bottom, which is x over 22. Okay, the way to solve is cross multiplying. Okay, think of that bottom number crossing and multiplying with the top. So on one side we get 6 times 22, which is 132. And on the other side we get 12 times x, or 12x. Then you only have one last step. You divide by that number in front of the x, and 132 divided by 12 is 11. So x equals 11. Okay, and that makes sense. We can see here that the small triangle, all of its side lengths are half the measurement of the corresponding sides of the larger triangle. So that should be 11 if the corresponding longer side is 22. Here's our final example. After drawing these two triangles in your notes, and again, they don't need to be perfect, okay? But I'd like you to try to set up a proportion, right? That's that equation, a fraction equal to a fraction. Okay, so some fraction equal to another fraction. Remember, you either need to put both of the smaller triangle on the top or on the bottom. And then we're going to solve for x. Now notice this time x is within the measurement for that side length. It's not the side length itself, and that's okay. So take a moment, maybe pause the video, and try to write your equation. So one way to do this, as we match up sides, notice that this side of 77, it looks a little bit shorter than the 11x plus 11. So I need to match the 77 up with the shorter side of the small triangle. So I'm going to put a 77 in the top over a 21 on the bottom. And that leaves the 11x plus 11 side matching up with the 30. So again, the 11x plus 11, that's on the larger triangle, so that needs to go in the top, and then the 30 would go on the bottom. Okay, now as we use cross multiplication to solve this, let's first do the 77 times 30. I'm going to go to my calculator. 77 times 30 is 2,310. Okay, bring down the equal sign. Now, as we do 21 times 11x plus 11, we need to use the distributive property, right? This is like a 21 parentheses 11x plus 11. So we need to do 21 times 11x and 21 times 11 as we rewrite this down into our equation. So I go to my calculator, 21 times 11, that's 231. Okay, so first we get 231x, and then 21 times the 11 is just 231, so plus 231. And now we just have an additional step in our solving, right? We need to get this 231 canceled out and brought to the other side. Okay, and then 2,310 minus 231, well, that is 2,079. Okay, bring down the 231x. We divide by that 231, and we get x equals 9. Okay, so back up at this missing side here where we have our x, okay, if x was equal to 9, right, we'd have 9 times 11, which is 99, plus 11 would be 110. That's the actual length of this side, okay, but x is 9 to give us that length. And that will end this skill video for Skill 6 of Unit 2.